Hello, in this video, we'll demonstrate how to configure Cisco ACI, VMM, and HP Virtual Connect integration. So Cisco ACI is the Cisco latest, switching fabric for the data center, and the VMM is a Cisco technology tool work with the hypervisor like vCenter and Microsoft System Center to integration VM networking. So here's the diagram we'll cover today. So pretty much in this demo, we'll have a Cisco ACI fabric, which consists of two leaf nodes and one spine node. And we have a APIC controller. Everything is up and running. So the focus of this one video is not trying to educate users how to, do the basic ACI installation and the basic concept but more focus on the how to get ACI working with HP Virtual Connect, for the hypervisor Virtual Connect, virtual machine networking. So uh, we have the ACI fabric up and running, and we have a vCenter over here, and we have the HP blade inside the HP blade system C7000 enclosure. So the goal of this video is trying to have the hypervisor ESXi connectivity, and the virtual machine on the host have the connectivity from the C7000 plate enclosure through the virtual connect through into the ACI fabric. So ACI can provide the persuasive gateway. So we'll cover that as well. So this is a brief uh, diagram, pretty much several key things we want to mention. So first thing, typically for the customer, many of them they are familiar with the Cisco VPC, Virtual Port Channel. So we can still use the Virtual Connect to config into ACI Cloud in with a Virtual Port Channel technology. But the key thing for Virtual Connect is, assuming you have a two Virtual Connect module here for the hardware redundancy, and per Virtual Connect module, you will have a dual link. That's a typical cabling. So dual link, into the two leaf nodes, and for the other Virtual Connect module, we'll have another dual link into the leaf nodes. So on the leaf side, we need to create a two Virtual Connect, two VPC per leaf switch. So assuming you have a VPC1 over here and the VPC1 here for the purple color. So VPC1 in the ACI cloud will matching and then connecting into Virtual Connect Module 1. And VPC2 on both leaf switches will matching and connecting into Virtual Connect Module 2. So that's the note we want to put it over here. So for the VLAN coverage, we have about 4 VLANs. So the first VLAN is the VLAN 160. This is more like my ESXi, management, VLAN. And also I'm using this VLAN to reach my existing data center network. And my vCenter is not inside the ACI cloud. It's more like connecting with my existing networking. So part of the setup is we need to make sure the vCenter is able to connect with the hypervisor VM kernel interface over this VLAN. Another 3 VLANs for the demonstration is VLAN 171, 173, and 172. So pretty much a 3 VLANs. We will try to set up, three EPGs inside the ACI, just to show you how, dynamic, VMM for the VCI, ACI working to provision the, port group on the DV switch side. So this is just a 4 VLANs we'll cover, in this demo. And the one thing really important, coming from the traditional networking background for any network admins, so ACI for all these VLANs, it's really doesn't mean too much inside the ACI fabric. So this is only one of the ways for the ACI to encapsulate your end user traffic into the ACI cloud. Right after inside the ACI cloud, ACI will strip out this VLAN header and will do the VXLAN forwarding inside the ACI cloud using the ISIS the layer 3. So this is some concept change you have to get familiar with when you work on the ACI fabric. Okay, so This is a basic topology diagram. This is the kind of steps we need to go through. I know it's kind of a little bit crowded, but trying to fit everything inside one page. So first, we need to review a little bit about the virtual connect configuration. The focus of this is not really on the virtual connect, because the virtual connect has been in the field for many years, but there are a couple of things, virtual connect we need to pay attention when working with ACI. Okay, after we go through this, then we can go through the ACI configuration. So that's the majority of this video will cover. Okay, so this is the first step. We'll cover VLAN pool and then create a VLAN domain. One is a physical, one is a VMM domain, and one after that is a attachable entity policy and the policy group, and after that we'll create the switch profile. This is kind of the physical layer, so the user can have the port ready to have VLAN and the domain ready for the physical port. In order for port to be active to switch the traffic, you also need to create a tenant and the EPG and all this private network, the context and the bridge domain associated inside the tenant. So this is will also cover the second part of the ACI configuration. So I want to give you the brief outline about what we will cover today. Okay, so let's take a look at on the virtual connect configuration. So this is a virtual connect manager 445. This is at this the time of the recording. This is a pre-release version, so you will not be able to find it on the hp.com to download. But it will be released soon, so users can have the virtual connect to work with the ACI VMM integration. So the virtual connect is the I/O module for the HPC 7000 blade enclosure. So the here's at this moment, there's two ways to manage the virtual connect module. One is called OneView, which is HP latest infrastructure management software. Another one is the legacy virtual connect manager. So inside over here, we are using virtual connect manager. The reason for this version is this version has one important LLDP enhancement. So basically we enable the, if I can go back to the diagram. So the key thing for the ACI to work with the HP interconnect or any blade enclosure inside, including UCS, is to have the either LLDP working or CDP working. So the LLDP, so historically, Virtual Connect is able to support LLDP on uplink, but not on the downlink. So downlink going to the server side, LLDP was not enabled before 445. So we definitely need this feature to enable that. The way the APIC Virtual Connect virtual machine integration working with the vCenter is by LLDP or CDP, which Cisco will UCSB series blade will use a CDP to work with the AP controller. So for the other third-party blade vendors, so LLDP is the way to get it working. So the way APIC is doing the policy programming is, the APIC will see all the LLDP uplink uh, for the virtual connect module on the leaf side, and also because of the right now we enable the downlink LLDP, the vCenter has the knowledge about for each individual ESXi host, what's the uplink, kind of information. So we have two sides of LLDP. So APIC will know the leaf nodes LLDP from the virtual connect uplink, and the APIC will learn from the vCenter events about the ESXi host uplink for the virtual connect information. So the APIC controller will do the correlation to understand, okay, for a given ESXi host, for a given virtual machine, what's the path, what's the physical module path from the virtual machine, from the ESXi host into the virtual connect module and into which port into the leaf nodes. Then it can push the policy onto the node ports. So this is very important. So later on, after we set up the tenant, we'll show you how to verify the connectivity from the all the way to LLDP connectivity from the host into the virtual connect, and from the virtual connect into the leaf. In order to for VMM working, you have to get this two legs LLDP neighbor discovery working all the time. So another question the user may say, okay, I don't have a virtual connect manager 445. Latest is a 440 or 441, or I'm using the HP OneView 120, and latest SPP doesn't have the 445. Can I still have the my blade enclosure working with the ACI? Yes, of course. The pretty much the for the APIC to working with any server or virtual machine, it's kind of two ways. One is by we call it physical domain or static bonding. So pretty much if you traditional way, if you know these four VLANs, it's the you want to statically define on the APIC and statically associate on the port. That's okay. And pretty much you follow the traditional APIC configuration working with rack mount server. You just need to make sure in the end user encapsulation VLAN, many times you want to use a tagged, which is a default under the port configuration. So there's nothing special here. So the only the benefit of VMM is the APIC is able to dynamically provision port channel, not the port channel, sorry, the port group for the for a DVS it created earlier. So then for the VMware admin, it doesn't have to care which VLAN is going to for my web EPG application EPG. You can just change, attach the virtual machine NIC into the the port group, which has a very nice name convention. So that's the makes the job easier for the network admin working with the server admin. So two ways, if you want to get a VMM working with HP Virtual Connect, you need to have any version after Virtual Connect Manager 445, or later on when the OneView SVP have the 445 embedded, it will get it working. Before that, you can just follow through the traditional regular, the ACI configuration with the rack mount server, but usually you want to enable the VLAN tagging for multiple VLANs coming into one port channel. Okay, so that's some, the concept covered. So let's take a look at Virtual Connect Manager. So in this video, we'll not cover the Virtual Connect Manager basic configuration. Pretty much you can, if you search YouTube or hp.com white paper, search a Virtual Connect configuration, you should see a lot of, good hits. Okay, so this is the output. So one thing, first I want to point it out is, uh, this is strictly for LLDP discovery. So the first thing is so far through the testing, we see when the OA HP C7000 OA and the uh, Virtual Connect Manager enabled IPv6 addressing, it kind of mess up with the ACI neighbor discoverer, so it looks like, whatever IPv4 management address we send out to the ACI, the APIC, the doesn't, handle correctly. So one thing you want to make sure is, you don't want to any IPv6 enabled for the virtual connect. This is the interconnect bay 1.2, which is a two virtual connect module, to have any management IPv6 address. Okay, so this is the one thing you want to make sure on the OA side. So on the virtual connect side, you log in, you go to the IP address. This IP address is pure for management. It has nothing to do with your hypervisor data. traffic. Okay, so you want to make sure you are not in the IPv6 mode. That's pretty much saying, okay, I don't have any IPv6 management address assigned. Okay, and then I think on the OA side, if I can uh, go cover really, this is a enclosure-based IP addressing. You can see if you have the one IPv6, but there's another one called enclosure TCP/IP setting. This is the for general. So this is the for the on the OA side. You want to check it off, because if you check it on, if you have this enabled, then the interconnect virtual connect very likely will derive some IPv6 address. Okay, so you want to make sure it's disabled for the LLDP. Again, this is for VMM integration. If you don't need VMM integration for the ACI, you don't need to worry about this. Okay. Another thing is, so for the virtual connect manager, so typically it has two management IP. If you go to the IPv4, go to interconnect base, you can see it's 103, 104. So 103 is for bay 1, 104 is for bay 2. So this is more like for the management IP, for in-band management Ethernet access. So there's another IP for management. It's optional. By default, it's not enabled. But in order for virtual connect failover or that, working with ACI, so far, because we should have this enabled through the testing. If you do not have this enabled, when you have the virtual connect, the manager failover or module failover, on the ACI side, there's some like conflict information. The old information was not being refreshed. You have to manually sync between the ACI and the vCenter. So far it looks like there's something going on between the ACI and the vCenter. Sometimes it doesn't get in sync correctly. Okay, so in order to ease that pain, so pretty much we want to use so inside LLDP there's a very important field code this one. Let me show you. So this is the ACI leaf nodes. This is the one of the leaf nodes. Okay, so leaf node one. So this address, the two address very important is this one and this one port. So this is the management IP 127. Okay, so this is you can see this is my 127 defined here. This is the like virtual management IP. So if you define this, both modules, will use this one, this IP to advertise, management IP TLV. So when the ACI got it, pretty much it only look at this IP to know who is the other guy on the other side and this port number here. Okay, so right now if you do the show LDP neighbor, you can see my port is up and you can see this is my first module, Ethernet 19, and my second module, Ethernet 112. So if you go back to the topology, so pretty much each leaf nodes has a 19 and 112 connected into the two virtual connect manager, two virtual connect module. Okay, and then make sure you define this one. Otherwise, when you do the failover, you may get the traffic loss. Because of the out of sync status between the vCenter and the ACI. Another thing, okay, so that's pretty much taking care of the LLDP stuff. Another thing is with this 445 version, we want to 127. Let me take a look. Let's take a look at there's another important command you need to turn on. This is a virtual connect manager SSH interface. So if you do the show config, So this command. So you can do the show LLDP to know the status of the configuration. So by default, this one is called false. Pretty much, in order for virtual connect manager to send the traffic down, LLDP traffic down to the server side, we need to enable some, the attach LLDP packet with some tag. So this is how the virtual connect working with the server to enable the virtual connect unique FlexNIC feature. So, but from the user perspective, you want to make sure when you get the 445, you want to make sure the OA is not in the IPv6, virtual connect is not in IPv6. Virtual connect has a domain IP defined for the management, and another one is this one. You got to enable this one by typing this command. Okay, by default it's false. So without this one, your host is not it's not gonna work. And for the LLDP discovery. Okay, so let's go to so that's pretty much cover the some special things about LLDP. Another thing about for the virtual connect networking, we'll cover briefly about not about the so typically for the virtual connect uplink networking, you can either define a trunk or define a tunnel VNet. So right now, so either way works, but so you can see, this is my trunk configuration. Again, the virtual connect initial configuration, you should, check some other documentation, but this is, typically many customer using this, so 160 is management for the host. 171, 172, 173 is for the three VLANs for the EPGs. Okay, so you define one site, for aim for uh, for one shared uplink set for the virtual connect module one. You add the port, which is X5 and X6 over here, but it's not showing up because right now I'm using the other option to configure the networking. So this is the one option. You define two shared uplink set and to match the VLAN number, and then later on in the server profile, you let's take a look at the server profile configuration. So this is more like VMNIC 0 and VMNIC 1, okay? So when the virtual connect provision the server blade. So when in the so you want to, assuming you are doing a shared uplink set, then when you define the uh, networking for the server side, you want to drag everything onto the server side. So all the VLANs will be patched into the server uplink. Okay, so you want to do it on two sides, and so you can enable untag, make sure it's the uh, management traffic is untagged over the wire. So if you want, that's up to you on your vSphere design as well. So, but pretty much that's one way you do that. But the one thing you want to make sure is understand is right now for the virtual connect downlink, each physical port, like each 10 gig, you cannot define up to more than 162 virtual networks. Okay, so assuming one important thing on the virtual connect on the ACI is later on when we go to the ACI cover the configuration, you want to define a dynamic VLAN pool for the ACI to use. But this VLAN pool, it can be one VLAN or 10 VLANs or 20 VLANs. You can define up to 4K VLANs. But all this whatever VLAN defined over here, if it's a VMM integration, it can be picked by the APIC to be programmed on the DVS switch side. Okay, but in order for them to map, then your virtual connect has to define its VNet. Okay, so assuming you define a 400 dynamic VLAN pool here, back over here, remember virtual connect downlink, we have a 162 VNet, so you cannot fit 162 VLANs into for the one-to-one mapping with VNets. So that's not gonna work. So for shared uplink set to work, you need to make sure your VLAN pool is below, the around 160 VLANs, right? So that's the, one thing you want to make sure. Another option is I say, okay, I want to define a 4K VLANs on my dynamic VLAN for the ACI model, right? So what do I do here? Another networking, which is a very unique feature for the virtual connect, is the tunnel mode. So which is the one I'm using right now. So the tunnel mode is more like if you define a tunnel mode, in general, you define virtual connect as a pure pass-through module plus a server profile, benefit. So this is right now currently I'm using. Okay, you can see I define one tunnel. You can think about this one as a pseudo wire. Okay, so uh, pretty much you define, for the module one, you define one tunnel and include X5 and X6 over here, and do the same thing for the module two. Okay, and then you can see right now the reason is active standby because right now I haven't configured anything on the ACI side, so the VPC is not gonna work. So virtual connect is trying to make sure it's not, the network is stable, so it just pick up one port to put it to the standby to safeguard the network. Okay, so the same thing for the second tunnel B, but the only difference is, this tunnel network is for the second virtual connect module. You can see it's a bay 2. The way you define one network as a tunnel is when you define it, you need to make sure you enable this one, enable VLAN tunneling. Okay. So if you want to, fail over active, you want to make sure smart link is configured. So it's more like a link state tracking. So when the uplink, totally down, the downside, the server link will be brought down. So the VMware can do the NIC switching. Okay, so that's pretty much and on the server profile side, the way you patch the tunnel VNet, you just need to define one pseudo wire over the entire 10 gig port. That's pretty much it. So pretty much you have one pseudo wire from server side going to the module one, going to this port channel, and another pseudo wire tunnel two from the server VMNIC one and go up to the virtual connect module two port channel. Okay, so with this approach, really it doesn't matter how many VNet VLANs you define on the ACI. We don't even look at it. So we just simply pass back and forth between your vSwitch and the ACI. So later on when you add the additional VLANs, the beauty of the tunnel mode, you don't need to touch anything on the virtual connect module side because it's a pseudo wire. It works the same way as with passing one VLAN or 10 VLANs or 1,000 VLANs. Okay. With the mapped mode, you have to go into the virtual connect manager and define this, VLANs to match whatever added into your ACI model. Okay, so that's, two ways you config the virtual connect manager with the to work with the ACI and the blade. Okay, doesn't matter if it's ACI or not. It's just, I want to present with you the two options, so you understand what the design options you have when work with the virtual connect model. Okay, so I think that's pretty much for the section one. Okay, and then for the section two, let's go to the ACI model to provision the physical layer. Okay. Okay, so this is when you log into the AP controller, this is the GUI you see. So the first things, for ACI to work, you need to understand two layers. So first you want to make sure you prepared all the physical ports to be ready to be consumed by the EPG. Okay, the real entity, the real the scope of who is talking to who in the ACI world is by the EPG by the contract. In this video, we are not going to cover any contract or filter, but that's up to other Cisco videos. But pretty much the first layer, the first part, we need to get this all the physical interface ready, including the what's their LDP policy, what's their CDP policy, and we also need to configure the vCenter integration to create a VMM domain in the ACI. And after you are done with all that, then we can go into the tenant and then create a tenant and associate the EPG either by static binding or dynamic associate the EPG with a VMM domain. Okay, so let's take a look at the first leaf nodes. I have two leaf nodes open here. So pretty much right now, all physical cabling is up and running. So you can see this guy, second leaf also have the same topology. But if you do take a look at the show VPC, there's nothing here. It's just, one is the the domain ID is up. I'll show you where to see that if you do the show VPC here. And if you do the show interface brief, so the ports were kind of focus on this is from the physical ports perspective. It is kind of 5 ports. Actually, we'll stay on the leaf 2 for most of the time because leaf 2 has this outbound connection to the vCenter. So leaf 2 Ethernet 1.1, we need to define this one as the to accept the tagged VLAN into for the VLAN 160. And 9 and 12, they are part of VPC physical link. So pretty much these three. So let's take a look at the configuration for stat link interface status for the leaf 2. Leaf 1 pretty much the same thing. You can see this Ethernet 1.1 out of service up, 1.9 out of service. So this is very normal. Okay, out of service is just right now you haven't prepared your interface to be consumed by the EPG, unless you have the linkage between your EPG and your physical interface. These guys will be out of service. Okay, so we'll set up the APIC to get this guy up and running. Okay. Okay, so switch back to the slide. So for the physical layer setup for the ASIC, the first thing we need to create a VLAN pool. The way you do it, so APIC is the three. In this video, we pretty much will switch around between the tenants, fabric, and the VM networking. This is the main component, main tab going to talk with the vCenter. This is your physical layer, all the physical port, assign, the policy group. This is the access policy. Tenant is the EPG layer. Okay, so we'll cover this one to set up the access policy first. Access policy, you want to go to pools, you want to go to VLANs. Okay, so there are some other existing VLAN pool created. It's okay. So we'll do the HPVC demo static pool. Static outside VLAN pool. Just to make the name easier for you. So this is static. So pretty much, dynamic is more for your vCenter, integration. Static is anything you work with any static switch or static rack mount server or static the Blaze server. So you want to do the static. Okay, so unless you have the VMM, usually you want to define the static VLAN pool for the end user encapsulation VLAN. Again, this VLAN has nothing to do with the inside. This VLAN is nowhere to be seen. There's no VLAN on the ACI wire. It's a layer 3 fabric. It's all to how to take the inbound traffic from the users. Okay, so we can see right now. Oh, in our example, 160 will be the static because this guy will to the static, so I can have the connectivity here and connectivity down to the blade. So remember, my blade is it's the it's set up, but it still cannot talk outside the enclosure because ACI fabric has not been configured. So the first of things, in order to get the VMM, the to LLDB working, we need to add the blade into the vCenter and add the VM NIC. Okay, so we'll define this guy as a static IP VLAN pool and these three VLANs as a dynamic. Okay, so we need to create, go back to the slide, two pools, one static for management and one dynamic for ACI, for VMM. Okay, so we'll make it simple, 160, 60, submit. Okay, we'll create another one, HVC demo dynamic VLAN pool. So we'll keep the default. So this guy will use 171 and 173. Okay, so the next step is you need to create the domains. Okay, so one is the physical domain and another is a VMM connection domain. So let's take a look at the physical domain. So uh, there's one I did testing earlier. So we'll delete it. We'll create a new one. HPVC physical domain. Okay. A, uh, a, AEP, we'll leave it later, so we can associate it from AEP side. But in the domain, we want to make sure for the physical domain, you want to associate with the physical static pool, okay? And we need to create another vCenter uh, domain, okay? So the vCenter is here. Okay, so right now my vCenter doesn't have any hosts, right? So I have a data center called the ACI data center. So my vCenter is out here. Okay, so in order for the initial connection between your vCenter and AP controller, you need to have kind of some AP controller typically have outbound out of band management, so this guy can talk with each other. you know so let's take a look at the configuration where to set it up. So you go to so we create a physical domain for the static 160, and then we go into the VM networking, go into the policy, go into the VMware. So we need to create a new vCenter domain. Okay, so we'll call it HPVC demo. This name will be created. I think this name will be the DVS created on the vCenter. So we'll just use this name. Okay. Attachable, we haven't defined anything yet. AEP, we'll leave it there. We'll come back inside AEP to associate with with domain. So for the VLAN pool, you want to make sure it's the dynamic, and then you have this vCenter credential. Uh, HPVC vCenter show. So this is your vCenter password. Okay, vCenter, this is where you have this vCenter IP address. Okay, so my vCenter, I believe this is the one. data center. This one has to match with your exactly matching with your data center. So ACI-DC, you need to type it. Management, this is not a must, so we'll proceed further. Submit. So at this moment, if they are talking, a DVS switch should be created. Let's take a look at the. Okay, there's a fault here. So let's take a look. The fault is read when. Okay, let's do some troubleshooting here. So let's take a look at to see if I can define AEP first. So it looks complaining about some valid access profile. So I guess that's the problem. So let's take a look at the. So this in the step outline is the next one. So I'll create this one first for the dynamic for the vCenter to consume. Okay, so the way you go is Fabric. You go to the Fabric policy, and you go to the global policy. You go to the access policy, and you go to global policy. We'll create a new one. APVC oh, vCenter AEP. Okay, so we attach it here. Physical demo DBS update. So you can see the encapsulation. This is from that dynamic beacon pool. We don't need to define the interface first. So let's click finish. Okay. So let's go take a look at the VM networking side policy. So raised. Okay. Okay. So actually, I think the reason is here is over here I didn't select the credential. Okay. So even though I defined, I need to associate my vCenter IP with the credential. So I take a look, submit. Let's take a look, file status, clearing. Okay, so it's good. So that's it's did disappear. Okay, so right now I create a folder, you create a DVS, you create a uplink. That's pretty much, but no port group defined. Okay, so the next step is to create the uh, access entity policy. Okay, so one we need to one for the physical, one for the dynamic VMM. I already created dynamic, but there's one thing I need to do. So let's see. So yeah the let's create the physical first. I'll go to the fabric access policy, global policy, attachable. So this is the one I created for the dynamic. I'll create a physical HPVC demo physical EP. You want to make sure you link to your physical domain so you can get the IP range defined in that domain. I don't need any interface selection right now, so we'll do that later. There are different ways, different flows, but this is some ways I find useful for me. Uh, so this is the physical. You can see it's connecting with the physical. This is the physical. This is a VMM. Okay. Let's. So the next step is if you see my notes, because the VMM is kind of special AEP. It also control down the vSwitch configuration. So if you right click the AEP, you need to do this. So for Cisco side, you need to enable CDP, but for HP side, we'll do the disable. We need to. So this is the tricky part. I'll enable LLDP. So this one is the config the DVS, the uplink LLDPs to work with the virtual connect downlink. Okay, so this is the one you want to make sure you select right. So this is the policy. You just the very simple configuration. You just say like a CDP disable, CDP enable. Over here, if you see the LACP, the one you choose is the one whatever you name it. You need to select the MAC pin for the virtual connect, because the virtual connect for the not for the virtual connect. Actually, this is more for the ESX host. On the ESX host, you can do different, the pin by virtual port ID, LACP, all that. So this is one you want to choose. This one will match in with the default port ID, hashing by port ID. If you choose this one, the port group created will try to use the LACP, but the virtual connect right now we don't work with the LACP for the downlink, right? Because you have one server connecting here, connect here, so we are not doing the VPC here. So the server teaming policy should be the default uh, port ID pin. Okay, so you want to make sure it's the MAC pin. You click submit. Okay, so this is the one for the virtual connect for the if you want to do the VMM integration. So for the other one, it's mainly for the physical for this link. You really don't care. Okay, you don't need that. You just need to define the associate with the VLAN ID. That should be it. Okay, so right now the next step is we'll take a look at the step here. It's we need to define the policy group. Okay, so we need to kind of define three policy group here. The first one is for that single port for the outbound access to the vCenter. That's a plain, the single port access group. The other two is for the virtual port channel access policy group. So the reason you need two is more like identity for your VPC. If you create one and add, the four links, it will try to only create one port channel, and you will see some, active, someone is a standby. So in order for you to have a two port channel for the two virtual connect module, you need to have two policy group defined. So totally that's three. So let's do that. So we'll scroll up. We'll define the interface policy. We'll define the policy group. Define regular, single port. Just do this. This doesn't mean it's, the untagged traffic. This is not like access mode. It's just a plain single port. You can still take the tagged traffic. HPVC demo outbound port P group. Okay, so this is where you define the if it's 1 gig or 10 gig. Uh, because the other side is Nexus, we can use CDP. We can enable attachable. This one you want to attach with your physical. So this interface can get the uh, VLAN ID inside using a AEP entity. Okay, submit. Then we need to define two VPC. Okay, so this one will do the HPVC VC1 AEP. This is for the virtual connect module 1. So we don't do CDP, so we'll just do the LDP for the interface. You want to use the LACP active. So for this, policy, you want to enable the active. If you do the virtual connect by itself is more like LACP passive. So you want the APIC leaf node initiate LACP negotiation. Okay, so you want to attach it to your vCenter AP because this will go into that vCenter, the blade, okay, for the VMM. Let's see what else. That's pretty much it. Okay, this is for the first one. We'll create another one. HPVC, VC1, sorry, AEP. This is pretty much the same thing. You just need to make sure it's two entities. Disable, LDP enable, LCP active. Then you use the same one. Okay. Okay, so now your policy group is defined. So now we go to the step 3. So we go to step 3 is to define to use the APIC wizard to attach to select a real interface and attach all this policy group and in turn the AEP domain and VLAN pools. Okay. So one thing is interesting is let's focus on the APIC 2. So right at this moment, it's everything is out of service. It's okay until we attach the EPG, it will be out of service. Show VPC, you don't have anything. Okay, so and the show port channel. Yeah, this is for some other connection. So let's take a look at the. So the way I like to do is I go to quick start. I use the APIC wizard to do that. I click this button. This is you can see I have some other interface already in use. The one we are concerning is the 19, 112 on both switches and the 11 on node 103, which is the second leaf. So the way we create it is here. We select the new one. We'll create the first one, the single port. Okay, we'll go to the second leaf. Switch profile, we'll say HPVC outbound port. Then we create the select interface. So we select 11 interface selector port 1. This name to me doesn't matter that much. Select the name. Interface policy group over here. See, that's the reason we want to prepare this one ahead of time. That's a flow I like. Okay, so over here you need to make sure you do save twice. Eventually you need to submit for the whole chain, but right now it's a save once for the ports and a save once for this profile. And you can do the submit now, otherwise the submit will be grayed out if you don't press the second the submit. So we'll create another two for the port channel. Okay. This one we need to do the both switch. Switch profile is HEVC VC1. VC1 we know it's port. We'll do the interface. We'll do the I think the port 9. Port 9 and HPVC VC1 selector. So Sorry. This is very important. You want to switch it to the VPC. Okay. So it changed to the VPC policy group. You only have two. So pretty you define one, the save and the save. Okay. So this is the first VPC created. Uh, Another is the before I uh, before before the VPC can happen, I forgot to mention there's a step you need to do for the VPC peers. Okay, so you need to first set up the two switches to for them to establish peer, the relationship. So pretty much this is more like your old, VPC domain configuration. You give it 100 or 101, you select both switches. Okay, and that's pretty much it. Then then these two nodes will become a peer switch. Then under that, you can define the individual VPC port channel going to the user side. Okay, so just want to point it out. So we'll do the second one for the port 12 for both switches. Switch profile is the HPVC VC2. We'll do this one 112 HP VC VC2 selector. I forgot to this one. VPC, very important. Okay, VC2. Okay, don't select the VC1, otherwise you end up with a one per channel with a four links, and some will be the active, some will be the standby. Save and save twice. So pretty much we create a three switch profiles. Okay, to select the 1 and the single switch, and the 19 112 on both switches. Okay, now let's see if we can submit. Okay, the way you check is you can take a look at the switch profile. This is the one we created. Okay, so let's take a look at the show VPC. So now you can see don't worry about active VLAN because we haven't attached the EPG yet. So you can see the port channel 19, port channel 18, it's using VPC ID. So one thing I find it a little bit weird is so even though for the VPC port channel 349, the on one side is tend to use one number different than the other one. So this guy is a port channel 19. This one is I guess it's the same in the let's say for 350, right? This side is port channel 20. This side is 18. But this number doesn't matter. The number matters is this ID. Okay, this is old VPC concept. Okay, so right now both per channel. So uh, so what's the next step? If you take a look at flowchart, so we're done here. Okay, so right now all the physical port access is still there. If you do the show interface brief, the port will be still out of service. That's the reason we haven't created a tenant yet. Okay, so this port are not ready to use. It's ready to use, but you need to create a tenant to consume it. Okay, so now we go here. So actually right now I have the continuous ping going to the 160.51. So I'm somewhere. My jump server is here in the cloud, in the my old, the network. I'm trying to ping inside the 51, which is my ESX host. So in order for that to work, I need to get this link patching the traffic through the EPG and this traffic going to the and also I configured my virtual connect as the kind of a pseudo wire path through for the tunnel. So right now my virtual connect side should be set. So I just need to finish the EPG attachment on this interface and the two virtual port channel. That's what we are going to do next. So we are getting there. Create tenant. Okay, so let's create tenant. Okay, so we'll add a new tenant. PVC demo tenant. Uh, okay, so this is just a name. So we want to add a private network. Yes. This is more like a VRF concept. Okay, HPVC tenant P net one. We want to create a bridge domain. Good. This is more like internal VXLAN, transport, scope. So we need to do that. So HPVC and P1, PD1. Okay, so subnet, I don't need to, I can config one. Yeah, so I can configure right now. So if you go to my diagram, so I will config my VM to be, you know, using, 10.16.171 network. Okay, so I'll config my, ACI pervasive gateway, which is will be programmed on each leaf nodes to be 171.1. Okay, let's take a look. 1070. Private subnet, that's fine. Subnet, I think it's 24. Okay. So at this moment, I can add to some layer 2 extension. The way I do it, I will extend my EPG to that single link. So I don't need to do this L2, L3. So I'll do the finish. So this is my tenant. I don't have an EPG yet, but I do have the network, bridge domain, and my VRF. So you can see it's the hardware proxy. So the known ARP or the L2 unknown will be sent to the spine. Spine will see its database for the learned endpoints. Okay, so unicast routing, that's the thing I want to do the pervasive gateway for the dot one. That's pretty much it. So we did this. Now we need to create the EPG, and the EPG I will create is the so I'll create one so I can have the connectivity here. So the bridge domain is very important. You want to associate with the single bridge domain you created. Uh, okay, I'll create another one. Web app. We'll do the association later with VMM for the three web app and the DBAPG. Okay, but right now I'll just associate them with the. So I will not cover the contract. So that the important thing is to show the HP blade enclosure can have the activity. So the contract, there are many, the videos, the document on the Cisco side to show. So that's pretty much it. I will do the submit. So now if you go to the my business profile, application profile. So right now you can see I still don't have anything, my vCenter and my management network cannot talk with this hypervisor, so I need to get it down first. So right now, my main concern is this one. So in order for this to work, this either you do the dynamic domain association, which will do the web app and DB, or you do the static, path is more like port to binding. So we need to bind, three interface on this topology. We need to bind the ESXi manager for this interface and for the two port channel. Okay, so this is an interesting part on the on the interface layer for the physical access. We need to see this out of the service for these three ports. They should be up. Okay, after we do the association with the EPG. So let's do it. So deploy EPG. So we'll do the first one first. We'll do the O2 one encapsulation because I know it's the tagged traffic 160 coming in. So I'll do the tagged. Okay, so let's take a look at my interface. You can see right now if you do the show interface Ethernet 1.1 switch port, you can see right now allowed is a 2139. So that's internal VLAN for the inside ACI fabric. You can see the 2930. This is a very useful command. You can see the 2139 internal, so you need to look here. 2139 here. So that shows 2139 is the encapsulation coming from the user side, and the 21 is for the bridge domain. Okay. 39 should be for the EPG. Okay, so now we got one interface up. We have two more to go. Virtual per channel. This is a part, that's the thing, you got to make sure when you define policy group for VPC, you give it two different names. If you give it one name, it will be one per channel, virtual per channel. Okay, so we'll do the first one first. VLAN 160. This is coming down to the blade through the virtual per channel because I'm using it's a pseudo wire, so virtual connect doesn't do any tagging change. So on the ESXi, it's untagged. So we want to make sure it's more like we select this one. This is more like switch port native. Okay, so we are expecting untagged traffic from the host through the virtual connect pseudo wire, and we'll place into our internal VLAN here. 160. Okay, we'll do another one. 2. We do the same. 160. Okay, this part, let's see if we can get working now. Submit. So at this moment, if we wait for several seconds, it should work. Let's take a look at the show interface brief. I should see all three out of interface. VPC peeling down. Okay, that's interesting. Let me take a look. What's going on here? Okay, so if I do the show VPC showing the show native, it's the reason is there's a compatibility check. I think I know the reason. Remember when we do the AEP, anything with VLAN is around the AEP. If you go back to the fabric, go into the access policy, Go into the global. For the demo vCenter. So here you can see my AEP for the VLAN only associated with my VMM domain, which is a 171 to 173. I need to also associate with my physical domain so I can get that 160 in here. So let's see if it works. Let's make sure my VPC is okay, now it's working. So it takes some time. You can, if right now, actually, if you go to the EPG files, it was complaining the referred object was not found, which is the VLAN 160. So because I didn't do the physical uh, association for that AEP, so right now it should be happy. VLAN, okay. So now you can see right now I'm pinging from this interface into this VPC into Virtual Connect into the ESXi host. So now we should be able to add some hosts here. So if I go to my inventory, so right now we'll just add a host. I'll post the video because it's a regular VMware stuff. Okay, now host has been added. So if you take a look at the uh, configuration for the networking, we should have two network adapter. We should have two. This should match with your virtual with the virtual connect, MAC address. Let's see if we can get access here. You can see 08 and 0C. The 08 and the 0C. Okay. So right now for networking, I only have a VM kernel, which is the management, which is all this time, all this effort trying to reach this guy. Okay. So I have this guy attached to the virtual machine, the small Linux attached to the, VMNIC one. So right now for the networking side, remember we have this DVS created, but nothing there. So first thing we need to do is to add this host for the VM. We'll just leave the VMNIC one there just to show VMNIC 0 for the concept. We don't do the migration, for now. Okay, completed. So right now the interesting will happen. There are several verification we need to do. So right now nothing config, but the uplink, the first thing you need to do is you need to wait here. So it's not, yeah, so it should be enabled. So let's take a look at vSwitch configuration. Make sure LDP is enabled. LDP is enabled. So after some time, here's the bingo. You see this. Still remember this 127 is the virtual content manager management domain IP. Okay, so this is D2, which is this downlink 2, which is this guy is in the server bay 2. That's called a D2. If it's this guy in the D1, D3, or vice versa. Okay, so now that shows with this version of the virtual content manager with this the command we put into the CRI, the LLDP neighbor discover is working on the downlink side. This is critical because the uplink for the virtual connect has always been working. So now the virtual connect manager now the APIC can do the correlation for these two legs of LLDP information. The way you verify is there's several ways you can verify. So VM networking, you go to the inventory, You go to the VMware, you go to your DVS, so you can see this vCenter. So now you can see it see my host added. So I believe it's VMNix 0. You can see this is the neighbor. So this is showing the host showing the virtual connect virtual connect is my neighbor and it's connecting to this information to the app. Okay, so host doesn't do any decision here. Host just showing this information. The vCenter knows. vCenter will in turn relate to the AP controller. The AP controller, for the topology, you can go to Fabric inventory, go to the unmanaged. Anything not, the AP controller and leaf spine is unmanaged. Okay, so right now, if you click here, you can see this is the end-to-end topology. So the AP controller knows from the vCenter how this guy connecting to Blaze Switch, and from the to the virtual connect, and from the virtual connect from the leaf node. If you do the show LDP neighbor interface E19 detail, it knows the leaf node is also connecting with the virtual connect uplink. Okay, so it's complete. With this version of code, we make the kind of the if you go to here, we make two modules behave like a one domain module. Okay, so it will say okay from this domain which is two module is connected with this ports port channel. And remember that my virtual content manager earlier I showed you the active standby before I provision the VPC. So right now, if we go to take a look at the port channel status on the virtual connect side, we should see active on both sides, on all four links. So active for the bay one, active on the bay two. Okay, this is a good status. Both leaf and the virtual connect is happy, and this AP controller is showing, it has one server link, VMNix 0. This is virtual connect module, virtual connect domain configuration. So now the AP controller know anything VM attached to this module, to this host, to the special port group, created later on, will need to be pushed. The configuration will need to be pushed to this port, to this leaf nodes. Okay, that's the whole thing about how the VMM is working. It's by LLDP with other servers and with CDP with Cisco. Okay, so now I think we kind of get to the end of here. So we verify the LLDP. So now we can add this VMM, the web EPG to the VMM. Okay, so the thing, if you go back to the DB switch, right now this guy only have the uplink, but there's nothing here. There's no VM attached to the port group. First off, we don't even have a port group. The way you do that is, uh, the whole point of this technology is on the APIC admin side, you go to the tenants, you go to your tenant, or you just use web. Okay, so in the web, there's entry code uh, domains. Now you can add this. Make sure you add the VMM domain association. Make sure you this vSwitch. We'll just do the immediate to push it so we can see the status. Submit. You can see right now it's there are some events happening. It's the port group is being configured, and the port number is the VLAN ID is 173. So now the VMware admin just can attach his virtual machine to into this. He doesn't need to care which VLAN ID. It's end to end. But the one thing, of course, on the virtual connect, you need to provision this one either by the individual VNet or by the tunnel VNet. Okay. So 173. Let's take a look at on the APIC side on the leaf node. If you do a show VLAN extended, so 173 here because 173 is the encapsulation from the user side. Internally, it will become a 45. And if you take a look at 45 here, you can see it's from the web EPG. And this is being provisioned on the following interface, which is the port, which is exactly two virtual port channel over here. So if you take a look at the show interface, Ethernet 19 switch port, you can see the 49, 173, 45. 45 is being added here. Okay, same thing for the 12. Okay, 1245. So now if I go into my VMware, uh, go to the host view, see that little virtual machine here. So right now, let's take a look at this initial new ping. This guy is configured with 171.101. I'm trying to ping the pervasive gateway configured on the bridge domain side. The one right now, this guy is not pinging, but because it's the the virtual adapter is just attached to the regular V switch. So right now, if we could attach this guy to bingo, here's pinging. Okay, so the way you do, you can even learn this. Take a look at this guy's IP MAC address learning. If you do the edit you to the network, so you can see the MAC is 2023. Show MAC address. I don't have lots of stuff. 2023 learned on the port channel 19, which is one of the virtual port channel, and it's a VP and 45 on the VLAN 45. Remember, show VLAN extended. Uh, 45 is my web EPG. Okay, so that's pretty much proved VMM working with the ACI with the latest the LLDP enhancement on the vertical manager side. Another thing before we go, I forgot to check the teaming. If you go to the networking, go to this guy. So this one is the default. So remember, if you check back in your AEP side, if you go to the physical layer, if you set that one to the LACP, even though you set it to the LACP off, it will create a LACP port channel for the uplink teaming, which obviously we do not want to do that. So I just want to emphasize again this vSwitch, the control stuff. You want to select the MAC pin. So another thing I want to show is we can take a look at the EPG for the endpoints. Operational. So this is important because the fabric is operated by the endpoints learning. You can see we learned from the MAC and the IP, and the source is the VMM, the hosting server, VM kernel, and this vCenter. This is the LLDP information for the virtual connect manager. Okay, thank you. Okay, going back to this one. So we approved VM the go to the virtual connect manager, virtual connect, and go to the ACI end to end. That concludes the demo. Thanks for watching.